Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, we have discussed about autocorrelation function of the random process and its properties. Now here in this video, we are going to discuss about cross correlation function of the random process. The cross correlation function of two random process x of t and y of t is defined as a measure of similarity between a signal and a time delayed version of a second signal. Consider two random process x of t and y of t. Okay, the cross correlation function of the two random process is defined as a measure of similarity between a signal and a time delayed version of the second signal. And it is denoted by the cross correlation function of the random process x of t and y of t is denoted by rxy of t1 comma t2 is equal expectation of x of t1 into y of t2. So two random process at the time instance, two random variables uh, at the time instance t1 and t2. So therefore rxy of t1 comma t2 is equal expectation of x of t1 into y of t2, which is equal integral minus infinity to infinity integral minus infinity to infinity xy into f of x comma y comma t1 comma t2 into dx dy. And this is the definition of the cross correlation function of the random process x of t and y of t. In this equation, substitute t1 is equal to t and t2 is equal to t1 plus tau. So now here t1 is equal to t, t2 is equal to t plus tau. So then rxy of t comma t plus tau is equal expectation of x of t into y of t plus tau. If x of t and y of t are at least jointly weights and stationary rxy of t comma t plus tau is independent of absolute time, and we can write rxy of tau is equal expectation of x of t into y of t plus tau. If x of t and y of t are two sample functions from the random process x of t and y of t, so x of t and y of t are the two sample functions from the two random process. The two random process are x of t and y of t. So for the two random process for the random variables are x1 is equal to x of t1 and y2 is equal to y of t2. Then the cross correlation function is rxy of t1 comma t2 is equal expectation of x of t1 into y of t2. So this is already defined definition of the cross correlation function. Okay, so the two random variables are x1 and y2. Double integral x1 y2 uh, f of x1 comma y2 comma t1 comma t2 dx1 dy2. If y1 is equal to y of t and x2 is equal to x of t plus tau, then r yx of tau is equal expectation of y of t into x of t plus tau. And this is the definition of cross correlation function of the random process y of t and x of t. If yx of t comma t plus tau is equal to 0, then the two random process x of t and y of t are called orthogonal process. If two random process x of t and y of t are statistically independent, the cross correlation function becomes rxy of t comma t plus tau is equal. And what is the cross correlation function of between two random process definition? Rxy of tau or rxy of t comma t plus tau is equal expectation of x of t into y of t plus tau. So two random process x of t and y of t are statistically independent random process. So expectation of x of t into y of t plus tau is product of the individual expectation, that is expectation of x of t into expectation of y of t plus tau. So this is the condition for the independent random process condition. Independent statistically independent random process condition. If the random process x of t and y of t are statistically independent and at least weights and stationary random process. So the random process are at least weights and stationary random process. The condition for expectation of y of t plus tau is equal to expectation of y of t. So therefore Rxy of t comma t plus tau or Rxy of tau is equal expectation of x of t into expectation of y of t. So that is equal x bar into y bar. So x bar is the expected value of the random process x of t. Y bar is the expected value of the random process y of t. So which is equal to constant. X bar into y bar is equal to constant. So this is the concept of cross correlation function of the random process x of t and y of t.